afternoon everyone. Welcome back to DDC classes. So hope you all are doing good. Now in our MCQ series today we're going to start with the central nervous system. Now respiratory drugs acting on respiratory system, that we are done with that. That is a short topic, so only few MCQs were there. So today we're going to start with the central nervous system. This is the very important topic that is for your GPAT, NIPER, DI, all the exams, okay, the railway pharmacist exams, for all the exams, this topic, the questions come from here. So let's start with our first question here, that says, it is from the IUPAC, okay, so it says the 2-bromo 2-fluoro 1,1,1 trifluoroethane is. So let's draw the structure first. So this is ethane. Okay, so ethane is 2 carbon containing, that it says at first position we have trifluoro. So 3 fluoro groups are attached at first position, and it says at second position it has a fluoro group and a bromo group. Okay, so this is the structure and they are saying which drug structure is that, and if we look onto the options it says halothane, isoflurane, sevoflurane or desflurane. So this structure belongs to halothane. Okay, so this is the structure of halothane. Here at first position we have trifluoro, at second position we have bromo and the fluoro group. Okay, so the A option is the correct option. Then the next question, it says in the given structure or the given reaction X is. So basically let's see on the reaction first. So this is the ethene. Okay, we have fluoro attached. Then in the presence of SBF3, it gives trifluoro and the hydrogen attached, and at 1 we have the fluoro. So at first position we have trifluoro and at second position we have 1 fluoro group. Now they are saying that on bromination of this reaction what we will get. Like right now we discussed this question that on bromination here a bromo group will be attached. Okay, and this particular group or this particular molecule is called as halothane. Okay, so this is the reaction that is for the synthesis of halothane. So here we get a halothane. So the answer is the first one again. Now the third question says ring present in phencyclidine. Okay, is it a pyridine ring, pyrimidine ring, piperidine ring or the pyrrole ring? So phencyclidine, we should know the structure for that. So this is the structure. Now there are 3 rings present in this particular structure. One is the cyclohexane ring. Next you have the phenyl ring, and this ring is called as piperidine ring. Okay. Now according to the options we don't have cyclohexane or the phenyl ring or benzene ring in the option. So piperidine ring is there. So piperidine is the answer, the C one. Now the next question we have fastest acting substitute of halothane. Means instead of halothane, if in our central nervous system we are acting on with some other drug that can substitute that halothane. Now what is that? Is that an enflurane, it is desflurane, sevoflurane or isoflurane? So basically it is enflurane. Okay, enflurane is the drug that can be used as the substitute for halothane. Now next we have again the question from enflurane. Now it says enflurane can be synthesized by halogen exchange of compounds. Now they have asked the question from the synthesis of enflurane. So during the synthesis, whenever there is an halogen exchange, okay, so what compound it forms? Okay, so they are asking about that. So let's look on to the synthesis of enflurane first. So let me zoom it. So the precursor here is methoxy 1,1,2 trifluoro 2-fluoroethane. Okay, this is the precursor. Now this on chlorination gives us 1-fluoro 1 difluoromethoxy 1,2,2 trifluoroethane. Okay, so this is, they are only asking that halogen exchange is done at what? So basically this only they are asking. Let me show you. Yeah, the options. Let me show you a minute. So it says 1-dichloromethoxy-1,1,2-trifluoroethane. Is that so? Or 1-chloro-1-dichloromethoxy-1,2,2-tribromoethane, or 1-chloro-1-dichloromethoxy-1,2,2-triiodoethane, or 1-chloro-1-dichloromethoxy-1,2,2-trifluoroethane. So here we can see that the D is the answer. Now here let me zoom it for you once again. So basically the halogen exchange, the product that we get is 1-chloro-1-dichloromethoxy-1,2,2-trifluoroethane. That is the option D here. Okay, so the D is the answer. So during the synthesis of N-fluorine, when there is an halogen exchange, we get this product, and this further on reaction with HF or HgCl3, it gives N-fluorine. Okay, this is the structure of N-fluorine here. So the D is our right answer. Now next we go on to the next question here. Starting material for the synthesis of thiopental is or are. So they are asking about the starting material in the synthesis of the drug thiopental. So let me show you the synthesis reaction. So in the synthesis reaction, here you can see methyl 2-cyanoacetate in the presence of this ETONA, okay, and ETONA at 50 degrees. Basically, this in the presence of this, it forms what? 2-methyl-2-ethyl-2,3-dimethylhexanoate. So basically precursor here we can say methyl 2-cyanoacetate. But if we look on to the options here, we don't have that option. That is the methyl cyanate one. Okay, now further on the process we get methyl 2-ethyl-2,3-dimethylhexanoate. Okay, let's see if this is on the option. Yes, the C1. Okay, the methyl 2-ethyl-2,3-dimethylhexanoate. Now this is the precursor for the synthesis, or we can say the starting material for the synthesis of the thiopental. Now here you can see this on further reaction at 120 degrees centigrade in the presence of an acid, okay, that is H2SO4 at 50 degrees. So this particular product we get, and what is that? Thiopental, a sulfur containing compound or the drug. Now next, so here's the answer. Now next question we have the fentanyl. Okay, the fentanyl drug they are asking about can be synthesized from 4N-propanoyl O-piperidine by N-alkylation with. So basically fentanyl synthesis, the question is from the synthesis again. So during the synthesis of fentanyl, they are asking what particular group it is added to or combination with this to get what particular group is added so that we can synthesize the fentanyl. Okay, so the answer is the A1, that is the 2-phenyl ethyl chloride. If we add this to the 4N-propyl oil piperidine group, okay, so by N-alkylation we get fentanyl. Okay, now the next question, halothane is metabolized to dash major metabolic product. So on the metabolism of halothane, what is halothane? Basically trifluoro, then here we have a chlorine, here we have a bromine, and here we have a hydrogen. So this particular halothane group on metabolism, how many major metabolic products we get? So let me 3 metabolic products we get. Let me show you what are those 3 metabolic products. So basically this reaction takes place in the presence of an enzyme. What enzyme? PYP2E1. Okay, this is the enzyme. this is in an aerobic condition. Okay, in the presence of an oxygen, this reaction continues, and the products that are formed are TFA, that is also called as trifluoroacetic acid, then bromide ion, then the fluoride ion. Okay, so what is the structure of halothane? I already told you that trifluoro, and here we have fluorine, here we have bromine, here we have hydrogen. Okay, so on oxidation we get trifluoroacetic acid. So this trifluoro is removed. Okay, then we get a bromide. So this bromide is also one of the metabolic products, and this chlorine also, this is also the chlorine ion, that is also one of the metabolic products. So these are the three major metabolic products that we get during the metabolism of the halothane. Next question we have, which drug is formed on bromination of 2-chloro-1,1,1-trifluoroethane? So it says, what 2-chloro-1,1,1-trifluoroethane? Let's make this structure first. So 1,1,1-trifluoro. I guess you must have guessed it till now, as we have discussed this a lot. For valency, it will be CH2. Okay, so on bromination, so on Br2 group addition, so basically what will happen, the Br will come here, okay, and there the H will be removed and only H will be there. So what is this? This is the structure of halothane only. Okay, we have discussed it so many times. Fluorine, fluorine, fluorine. So this will be formed on bromination of this 2-chloro-1,1,1-trifluoroethane. So halothane is the answer again. Okay. So this is the synthesis reaction. Then halothane. Now next question says 2-amino-5-chlorophenyl, 2-fluorophenyl, methanol and N3-amino-2-oxopropyl acetamide undergoes a ring formation. Means these two undergoes a ring formation in the presence of an catalyst. So what particular product we get? What is the name of that product? What is the name of that drug that we get on the reaction between these two in the presence of an catalyst? So let me show you the reaction. So this is the 2-amino-5-chlorophenyl, 2-fluorophenyl methanol, and this is N3-amino-2-oxopropyl acetamide. So on the reaction between these two in the presence of an catalyst, it results in the formation of, or basically the ring is formed between these two and it forms the midazolam. That is the name of the drug that it forms. Midazolam. Okay. So here the rings are formed by the combination. So these two rings are from before, but the two rings are formed, these and this, on the combination in the presence of a catalyst. Now midazolam is the answer. Now next question we have, reaction of isoflurane with HF and Lewis acid catalyst produce which drug? Okay. So let me show you the reaction. So this is the reaction. Now desflurane, okay, can be synthesized from the isoflurane. Okay, so isoflurane can synthesize desflurane in the presence of what? HF and SbF5, or we can say the Lewis acid catalyst. Okay, so or BRF3, we can also use that. That is the Lewis acid catalyst. Any Lewis acid catalyst we can use, and along with HF. So this isoflurane synthesize what? Desflurane. Okay, only the difference is that instead of a fluorine, that fluorine is substituted now with a fluorine group. So that is our desflurane. Now moving to the next question. So see is the answer. Next question we have, methoxyflurane can be synthesized by the reaction of 1,1-dichloro-2,2-dichloroethylene with. Okay, so methoxyflurane synthesis they are asking. So In methoxyfluorine, let me show you the synthesis reaction first. So this says 1,1-dichloro-2,2,2-trichloroethane in the presence of potassium hydroxide, or we can say KOH. It gives 1,1-dichloro-2,2-dichloroethylene. Okay, so basically a double bond is attached here and chlorine is removed. Okay, so that is this particular product we get, and this in the presence of an methanol and potassium hydroxide, KOH or methanol. It can give us what? The final product. Okay, that is the methoxyfluorine. So what is the product, or how it is synthesized? It is basically reacted with methanol. Okay, like here you can see it is reacted with methanol to give what? Methoxyfluorine. So methanol is the answer, A option. Now next we have question 5-ethyl 5-pentane 2-yle 2-sulfenylidene 1,3-diazinane 4,6-dione is the IUPAC nomenclature of which drug? So IUPAC they have given, which drug is that? We have to test. So let's draw the structure first. It says 1,3-diazine. So diazine means a ring with 2 nitrogens. Okay, so diazine, it will be a 6-membered ring and it will have 2 nitrogen. At what position? 1 and 3. So let's say this is the 1 position. So 1 and 3. 1, 2, 3. So at 1 and 3 position we have the 2 nitrogen group. Now it says at 4 and 6 it has dione, means 2 ketone groups are present at what position? 4 and 6. 1, 2, 3, 4. So here we have ketone. 5, 6. Here we have ketone. Okay. Now at second position it has sulfenylidene. So double bond sulfur, sulfenylidene group at second position. Now it says 5-ethyl. So at fifth position we have C2H5, and again at fifth position we have a pentane, and that pentane is attached with the second. Okay, the second carbon of that pentane is attached with this ring. So here we have CH2. Then 1, 2, 3, 4. 1, 2, 3, 4 and 5. So this is the structure of the drug, and we have to tell the IUPAC name. So it contains a sulfur. Okay, it contains a pentane chain. So if we look onto the options carefully, tacrine, it resembles acridine. So it has a 3 rings basically with an NH2, so it can't be tacrine. Then it says thiopentyl, vecuronium or paralidoxin. Now if we go on to the third option, it says vecuronium. Now I have already told you, whenever there is -ium at the suffix, then it will definitely contain a nitrogen with a positive charge, or we can say quaternary nitrogen. So in this structure we can't see any quaternary nitrogen. Okay, so this can't be the option. So C can be removed, A can be removed. Then D says paralidoxine. Now it says oxime in its name, so it should contain an oxime, but here I can't see any oxime. So again it can't be the option. So D is also not the option. Now B says thiopentyl. Now thio means sulfur. So here we have a sulfur group. Pentyl means a pentane. Okay, so pentane, here we have a pentane. So this drug basically belongs to the name thiopentyl. So this is the structure of thiopentyl only. Okay, so this is the thiopentyl drug, and that belongs to the IUPAC name belongs to thiopentyl only. Okay. Now the ring present in atomidate. Let me show you atomidate structure here. Now two rings are there. One is the benzene ring and the other is here the imidazole ring. What is imidazole ring? A 5-membered ring. Okay, that is aromatic, and at first and third position we have the nitrogen. So that is the imidazole. Here we have an imidazole ring. So if we look onto the options, Pyrrole, pyrazole, pyrimidine, imidazole. So this is the answer, that is imidazole. Next we have ketamine is a structural analog of. So what is the structural analog of ketamine? Is it a furosemide, 𝘿𝙄𝙎𝘾𝙄𝑖𝑑𝑒, glyburide, or phencyclidine? So let's look onto these structures first. So this is the structure of ketamine, okay, with a chlorobenzene group, with a cyclohexane that is attached with the ketone, okay, and the nitrogen attached there, the amine group. This is the structure of ketamine. Now, furosemide structure, it doesn't resemble the structure of ketamine in any way, so it can't be the structural analog. Then 𝘿𝙄𝙎𝑚ide, again 𝘿𝙄𝙎𝑚ide also I can't see any structural similarity in ketamine and 𝘿𝙄𝙎𝑚ide. Okay. Then we have glyburide. Glyburide also doesn't contain any structural similarity with ketamine. Okay, you can look yourself. Then phencyclidine, here, yes, we does contain some structural similarity. Like here we have a ring, same. Here we have a ring, same. Okay, so basically somewhat similar, and here nitrogen in there, nitrogen, but nitrogen is in a ring form in this. So phencyclidine is, yes, it has some structural similarity with what? Ketamine. So structural analog of ketamine is phencyclidine. Next we have given structure is. Now I guess right now we discussed this structure, so I guess you must have guessed the answer right. So this we have a imidazole ring, here we have a benzene ring again, bonded by the bridge, that is the CH2 bridge. Then here we have CH3 attached to that, and here we have an ester group again. Okay, so this particular ring belongs to what? Atomidate. Right now we discussed the ring that is present, the heterocyclic ring that is present in atomidate, we call imidazole. So there we discussed this. So this particular structure belongs to atomidate. Next we have nitrogen of the fentanyl is generally primary, secondary, tertiary, or quaternary. Fentanyl is the drug. Okay, the nitrogen, the present here, what particular type of amine group is present in that. So here we have amine group of fentanyl, and this particular amine group is attached by the 3 substitutions. Okay, so this is called as the tertiary amine. So the answer is the third, that is the C option, that is tertiary amine. Okay, now next we have 8-chloro-6-2-fluorophenyl 1-methyl-4-H-imidazole 1,5-A-1,4-benzodiazepine is generally. So basically they are asking what particular IUPAC name this belongs to which drug. So it is the structure, it is the IUPAC name of midazolam. Midazolam structure also we discussed. Okay, in the presence of a catalyst, the ring was forming between that, so that was a midazolam. So A is the answer. So midazolam. Now next we have the given reaction can be used as the starting material to synthesize. So the reaction is this. So what particular it will make, let's see. So this is the ring NH2, then we have chlorine group. Okay, either side you can make, they are in 1 and 4 position. It is reacted with what? The COCl. So on reacting them in the presence of Edelkraft acylation, it will give an acyl group here, and then again this ring will be attached here. Okay, so this will be the product we will be getting on the reaction of this. So they are asking that this particular product can be used as the starting material to synthesize which of these following drugs? Is it halothane, diazepam, ampurine, or ketamine? So let me show you. So this is the synthesis reaction. So here you can see the same starting material. Okay, that is chloro here, NH2 here, then we have an acyl by Edelkraft acylation, we have an acyl group here, then we have the ring attached. Okay, so this particular structure can be used as the starting material for the synthesis of which drug? diazepam. Okay, so diazepam is the answer. So this starting material can be used for the synthesis of diazepam. So I guess these many questions are only there for the today's video. Okay, hope you understood all the questions. Okay, all the explanation you have understood. Now we will meet you all in the next video. Okay, till then, thank you so much for watching. Thank you so much.